In the previous clip, I said that the application is cloud native. But what does that exactly mean? Cloud native is the practice of building applications that take full advantage of cloud computing patterns. These applications follow the microservices architecture. They are made of small pieces or services packaged in containers. Containers are packages of software that contain all of the necessary elements and dependencies to run an application in any environment. These containers are deployed on a container orchestration platform, like Kubernetes or Red Hat OpenShift. Container orchestration automates the deployment, management, scaling, and networking of containers. Enterprises that need to deploy and manage hundreds or thousands of Linux containers and hosts can benefit from container orchestration. By dividing your application into microservices, you can easily scale it and manage its changes without having to review the whole stack. Each microservice has an independent lifecycle, which means that if one microservice fails, the others will still be able to deliver, and we can have separate teams working on different parts of the application. As a benefit, applications can have shorter development cycles and are subject to more frequent changes. This is why you need DevOps. DevOps is a set of practices that, for a given application, unify the development and testing process, referred to as dev, and the deployment process, the ops part. In a traditional application development configuration, the development team and the operations team are separated. This organization has a few weaknesses, one of which is the "it works on my machine" syndrome, but also the amount of time taken to deploy new versions of an application. With DevOps in place, there's only one team responsible for the whole process, leveraging automation tools that make sure the application is deployed in a seamless and efficient manner. Granted, some rules and guidelines have to be made beforehand to determine how the automation will be going. However, one key weakness of the DevOps approach is that security is handled at the end, when the application is deployed to production. DevSecOps is a variation of the DevOps approach to enforce security practices. Instead of handling the security in a reactive way, DevSecOps aims at security by design, ensuring that security will be enforced in a proactive way with practices like code testing, vulnerability checks, image scanning and signing during the entire process, from building the application to deploying it into production to have it available to end users. Red Hat OpenShift takes DevSecOps principles to life, so we will be using OpenShift as a platform for our cloud-native workloads. It is a secure platform by default, and we will enhance its security with tools that we will take a look at in a future clip.